Hello YouTube, welcome back to my channel. I'm Sri Tips. This will be part 8 of the stock pot refining series, and I'm going to pick right up where I left off in part 7. I've got my solution out there evaporating down that has the copper and the platinum in it, and I want to get that platinum precipitated out of that solution. First, we're going to drive off excess nitric acid by rehydrating the solution with hydrochloric acid. And I'll demonstrate how that's done. I've got my black powders dried out in a weighed beaker, so now we can proceed with redissolving those and proceeding with getting the platinum to drop out of that solution with ammonium chloride. So here we go, part 8 of the stock pot refining videos. I've had this solution on since about 9 p.m. yesterday evening. I went in and knocked off and went to bed. It's at 149 Fahrenheit, 65 Celsius. Our solution has evaporated down to about the 75 ml level. I'm going to let that go on down until it gets down to about 25 ml to form a syrup, and then I'm going to use hydrochloric acid to expel the excess nitric. Over here I've got my black PGM powders, and we're ready to go ahead and refine those. First, I want to try to get the platinum out of this evaporated solution. Okay, here we have the solution of copper and platinum. I've got some hydrochloric acid here, and what I'm going to do, you'll notice that some of the stuff is starting to come out of solution. What I'm going to do is I'm going to cover this up. You normally would not cover it up to do this, but in order to show how this works, this is going to be a classic denoxing. We've evaporated the solution down to a syrup, and what I'm going to do is I'm going to expel the excess nitric acid in there by adding hydrochloric acid. I put the lid on top of it so that you can see the fumes coming out. There'll be some brown fumes evolving as we add the hydrochloric acid. Here we go. See those brown fumes forming in there? It's very light. You can't really see it that much, but those brown fumes are the nitric acid fumes departing the solution as I rehydrate it with hydrochloric acid here. I'm going to pull the cover off here. Let those fumes escape. I'm going to add a little bit more hydrochloric acid now, and then we'll evaporate it back down and add some more until we get all the nitric acid expelled from that solution. Reach down in there and get a little bit on a piece of filter paper here so we can do us a quick stannous test. See what we got. Just verify our platinum in solution. And there you can see we've got a nice orange stain indicating platinum in solution. Alright, we're going to go ahead and add some more hydrochloric acid here. I don't see a bunch of fumes coming out of there. I think it's fairly safe to conclude that we've got all the nitric expelled. Alright, I've got the heat off. I'm going to pull our beaker down off the heat and let it cool down. Alright, my solution's been allowed to cool for a few minutes. I've made a saturated solution of of ammonium chloride here. This is about 45 ml of liquid. And what I'm going to do now is I'm going to take the solution and I'm going to add it to the platinum and copper solution, and hopefully we're going to see some precipitate when the platinum comes out of solution. Here we go. Okay, here is our platinum out of solution. I'm going to add a little bit more of this ammonium chloride that I still kind of precipitating out there. Got a little bit of, add some distilled water to that. We'll pour it right in. Hopefully we'll get all the platinum to come out of solution. Here is our pure platinum salt. See that? That is platinum. All we have to do is filter this off and get it into a filter, and then we can burn it, and that'll be like 99.5% pure platinum sponge. Get a little of the solution on the end of our filter paper, put some stannous on it, and you can see that there's still platinum left in there, but not very much. I've got a filter set up. I got to get this out of here. Otherwise, it'll have a tendency to want to redissolve. I'm going to wet it with some 15% ammonium chloride water. You can't use tap water here, because if you do, the platinum salt down here will go right back into solution. I'm going to filter the ammonium chloride precipitated platinum salt out of my solution now. Now remember, this is this solution came from the failed sulfuric acid experiments. I was able to get that much platinum out of there. I haven't even got to my main solution yet. We'll do that next. This solution down here will still have a little bit of platinum in it. This will go into my new stock pot. Our platinum salt at the bottom of the beaker there. It's soluble in water, so water can't be used to rinse it out of the beaker. Instead, what I'll be using is a 15% ammonium chloride solution to rinse the platinum salt out of the beaker. Here's our platinum salt. That's ammonium hexachloroplatinate. And what I'll need to do is I'm using 15% ammonium chloride water here to rinse all the green solution off of it that I can. And then, like we did with the palladium earlier, I'm going to set this aside, label it, set it aside, and add it to the main batch when we get to that point. I'm just rinsing the ammonium hexachloroplatinate off right now with 15% ammonium chloride water. to get all that green solution off of it. And that green solution is copper. Can't use water here. If I tried to use water, that yellow precipitate would go back into solution, pass through the filter paper, and go back down in here in the flask. And I'm going to rinse it with a little bit more ammonium chloride water here until I get most of the green stuff rinsed out of it. I've got all the platinum filtered out. That's our platinum salt. Putting it in this beaker that says stock pot PT, and we'll save it for later. It's going to have some copper on it. You can see the green solution of copper still in it, so it's still going to be contaminated with copper, but that's okay. We can get this out later. Alright, I'm going to set this over here. We're going to do a little mini review. This was the failed sulfuric acid experiment. It's got some, must be copper sulfate in there because I had sulfuric acid in there. Here's the palladium that we extracted with DMG. Here's the platinum that we just extracted with ammonium chloride. This can go in my stock pot because it's just copper, there's no ammonia in here. And I'll put these two back in later on when we get to doing the mixed black PGMs up here. I haven't even started on that yet. Over here, this is going to have ammonia in it, so I don't want this going into my stock pot. What I'll do is put this back in the beaker, add some zinc, cement out any platinum group metals, filter them out, dry them, and then save that for a later refining. Alright, here we go. I've got the PGM metals down here. I've got 46.3 grams in there. The critical weight is 20 ml per gram. So I need to end up with 926 ml of this solution once I get those powders dissolved. I'll set it up here on the stir plate. I'm going to add about add some hydrochloric acid here up to about the 200 ml level. Here we go. Hydrochloric acid going in right now. Put a cover on it here, and then we're going to turn some heat on and get this thing heated up. And then what I'll do is add some hydrogen peroxide like before to get it to dissolve. I want to avoid using nitric acid because if I use nitric acid, then I've got to denox the solution of excess nitric. If I dissolve it with hydrochloric acid and hydrogen peroxide, I will not have any nitric to deal with. I've got it on a low boil here. I'm going to add a stir bar and begin stirring. I'm going to measure out about 40 ml of this 12% hydrogen peroxide and start adding it a little bit at a time to get the platinum group metals to go back into solution. Here we go. First dose. I get a stannous chloride test to verify that I have metals going into solution. Here I'm adding 100 ml of hydrochloric acid. Almost had a fantastic failure there. Better start putting this in by the dropper full. Here I turn off the heat. I get a temperature reading on the solution. It's 203 degrees Fahrenheit, 94.8 degrees Celsius. I'm adding some ice to try to cool the solution down for the next step in the process. Next, I take the beaker down off of the stir plate, and then I move it over here, and I'm going to transfer the solution into a new beaker to verify that I've got all the black platinum group metal powders dissolved. Here I noticed that there's a little sediment in the bottom of the beaker, so I stopped pouring, and I'll leave it in that beaker right there instead of pouring it into the new beaker to prevent it from becoming contaminated. In this shot, I'm going to prepare some ammonium chloride. I take the ammonium chloride and I add it to that graduated cylinder to about the 100 ml level with the powder, and then I top the graduated cylinder off with some distilled water to make a concentrated solution of ammonium chloride. Okay, here we go. I've waited for this moment for over 3 years to see how much platinum I'm going to get out of my stock pot. As soon as I started pouring the ammonium chloride in, I began to see some yellow precipitate forming. That was the platinum coming out of solution. I added a little bit more distilled water to the cylinder to dissolve the rest of that ammonium chloride, and I looked over and I seen the platinum salt coming down like a yellow snowfall. It was very beautiful. Okay, the platinum coming down out of solution looked so neat that I rearranged the camera to get a good shot of it. And as I did, the camera hit the lip of the dish and pulled the entire experiment off the sill of my fume hood, and it crashed all over the floor. I've never had anything like this happen, and I suppose if you do refining long enough, something like this is bound to occur. When it happened, all the blood rushed to my head. I had a hot rush in my head, and my knees went weak. It seemed like the end of the world. All right, we're looking at about between $1,200 and $1,500 worth of metal all over the floor there. I did get it all cleaned up. I will save the paper that I'm using to sop the solution up. I'll save that and put it in with my paper storage and burn it and try to recover those metals in a later experiment. I believe this probably never would have happened if it wasn't for me trying to jimmy the camera around to get the best camera angle to catch that platinum precipitating out of the solution. So this is a direct result of me trying to produce the video as I refined the metal out of my stock pot. Well, I suppose if you do refining long enough, something like this is bound to happen. It came crashing down when I tried to move the camera to get a good angle on watching the platinum precipitate out of that solution. It broke and went all over the floor. I didn't get anything on me. I had all my safety gear on, so not one drop of it got on me, but made a big mess. So I'd like to apologize to my viewers. This is a disaster that I cannot recover from. I've got it all cleaned up already. I've got it all sopped up with paper, and I've got all the glass in a bucket out there, and I'll get that neutralized and made safe to dispose. So once again, I'd like to apologize to my viewers. All I can do is clean up and move on, and that's what I intend to do. So thanks for watching part 8. This is the final video in the series, Ending in Disaster. I'm Sri Tips, signing off with this part of the stock pot refining videos. Thanks for watching.